So today we'll be considering chemistry. The subject matter today is chemistry, and the topic we'll be considering today is chemical combinations. We'll be talking about the laws around chemical combinations. Let's start off with laws. Laws are just regulation that governs a body, right? In your school, like secondary schools that you graduated from, there are several laws that were abiding. You know, like regulations. The ladies should always be on their berets. The guys should always use their belts. Your class must always be tidy. You must come early to school. Latest 7:45. Those are laws that govern the school system. So, in like manner, also in chemistry, there are certain laws that govern chemistry. And so, considering the laws that govern chemical combinations, we all know that matter is anything that has mass and occupies space, and they undergo changes. They can either undergo physical change or chemical change. So these laws that are considering, which are chemical combinations, are law that governs chemical change. Let's start off with the first law. We'll be considering law of conservation of matter. So let's state that laws of conservation of matter. Law of conservation of matter. This law states that matter can neither be created nor destroyed, but it can move from one form to another. Let me write that. Matter can neither be created nor destroyed, but can move or change from one form to another. In regards to chemical change, this simply means that the total mass of the reactant must also be equal to the total mass of product. Let's consider a chemical reaction. H2 plus O2 will give H2O. Let's balance this equation. 2 here, 2 here. So this law is saying that these elements, they cannot be destroyed nor created. So everything here must also be present on the product side. So let's calculate the mass here. This law, to validate this law, means that the mass here must be equal to the mass here. We know hydrogen is 1, right? 1 times 2, 2. 2 times 2, 4. Plus the atomic mass of oxygen is 16. 16 times 2, 32. And this will give 36, right? So as well here, hydrogen is 1. 1 times 2, 2. 2 times 2, 4. Plus oxygen, there are 2 moles of oxygen. That's 16 times 2, 32. And this is 36. Can you see they have equal mass? Let's consider another equation. Let's consider neutralization reaction. That's between acid and base. Let's say NaOH plus HCl. This reaction, neutralization reaction, is meant to give us salt and water. That will be NaCl plus H2O. Let's confirm if it is balanced. You will notice that before I calculate it, I usually confirm whether it is balanced or not. So it has to be in balanced state. This 1, this 1, this 1, this 1. 1 plus 1, 2, 2. Cl 1, 1. So atomic mass of sodium is 23, right? Of oxygen is 16. Of hydrogen is 1. These values right now, we all know that they are constant. But as you progress in chemistry, there are some of them you just know off and. But elements, let's say block D, block F, that you're not familiar with and you don't use regularly in equations you'll be given, right? Plus hydrogen 1, chlorine is 35.5. So 23 plus 16 will give us 39. 39 plus 1, that's 40, right? And this would be 36.5. And this would be what? 76.5. Let's move to the product side. Sodium is 23. chlorine is 35.5 plus hydrogen is 1 times 2, 2. Oxygen 16 plus 16. 23 plus 35.5, that would be 8.5, right? Plus 18. So let's calculate this together. I bought a calculator. I bought this type of calculator because I know this is the basic calculator you'll be allowed to use, and so we'll be doing all our calculations using this calculator and not the regular scientific calculator. So that's the 58.5 plus 18. That's 76.5. So this verifies this law that says that matter can neither be created nor destroyed, but can move from one form to another. In case of chemical reaction, that means the mass of the reactant must be equal to the mass of the product. Now let's consider another law. Law of definite proportion. And it's also called law of constant composition. So constant composition. This law states that for all pure substances, they contain elements and they combine in fixed proportion by mass. Let me write that down. All pure samples of a particular chemical compound contains the same elements combined in equal proportion by mass. Let's take that together. That means law of definite proportion, which can also be called law of constant composition, state that all pure samples of a particular chemical compound, emphasis on pure, all pure samples of a particular chemical compound contains the same elements combined in equal proportion by mass. Let's consider this compound, NaCl. You notice for sodium it is 1:1, right? Another element, let's say calcium chloride. This is 1:2, right? Let's consider H2SO4. This is 2:1:4, and this is fixed everywhere. Anywhere these chemical compounds are produced, the ratio has to be fixed. The law says that all pure samples of a particular chemical compound contains the same elements combined in equal proportion by mass. So the mass are usually definite. Let's take a verification question. Two samples of CO2, that's camphor oxide, were prepared by A, passing oxygen over heated carbon. B, passing calcium trioxide carbonate 4. Calcium trioxocarbonate 4 is CaCO3. The question says analysis of the samples of CO2 were prepared shown that in A, that's analysis A, 3.96 gram of CO2 contained 2.88 gram of oxygen. B, 2.20 gram of CO2 contained 1.60 gram of O2 as oxygen. Show that these results illustrate law of constant composition. Don't forget the law. The law states that all pure samples of a particular chemical compound contains the same elements combined in equal proportion by mass. That means no matter the geographical location where a pure chemical compound is produced, when varied, they will contain the same elements. They will contain the same elements combined in equal proportion by mass. So if it is 1:1, it will definitely be 1:1, no matter where it is produced. If it is 1:2:4, in that like manner. So let's do this. So we are told that 2 samples of CO2 were prepared using 2 different methods, and we are now told to illustrate that we should illustrate law of constant composition. That means they contain equal proportion by mass. Let me clean this up. So, sample A, sample B. Okay, let's write mass of CO2. Mass of CO2. Mass of CO2 in sample A is 3.96. For sample B, 2.20. Okay, so A, 3.96 gram of CO2 contain 2.88 gram of O2. B, 2.20 gram of CO2 contained 1.60 gram of O2. I was about checking to confirm those figures. Yes. Okay, so show that these results illustrate law of constant composition. To the solution, sample A, sample B, mass of CO2. From there we can see that sample A contained 3.96, sample B 2.20. So, and we also told the mass of O2, that's oxygen. Mass of O2, sample A 2.88, sample B 1.60. From here we can calculate our mass of carbon. We'll simply say mass of CO2 minus mass of O2. So mass of carbon, that's C, right? So it would be 3.96 minus 2.88. Where here it would be 2.20 minus 1.60. And so let's punch out. 3.96 minus 2.88. That's 1.08. 3.96 to confirm 2.88, 1.08. So 2.2 minus 1.6, 0.6. So for sample A, Mass of O2 is 2.88, mass of carbon is 1.08, sample B 1.6 is 0.6. Now let's calculate the percentage of oxygen in CO2. Percentage of oxygen. For sample A, it would be the mass of oxygen divided by the mass of CO2 multiplied by 100. For oxygen, we have 2.88 divided by 3.96 multiplied by 100. That's 2.88 divided by 3.96. That's 0.73 multiplied by 100. And that would be 73% approximation. For sample B, it would be 1.60 over 2.20 times 100. 1.6 divided by 2.2 multiplied by 100. So it's actually 72.73. If you approximate this, that's 73%. Or better still, don't let us approximate. Let's go with the actual value. So it would be 2.88 multiplied by 3.96. 8 divided by 3.9. Multiplied by 100. That's 72.73%. This as well is 72.73%. We can see for oxygen we have the same percentage. Let's do for carbon. By now you should know for carbon we would also get the same thing. Carbon is 1.08 over 3.96, which is mass of CO2 multiplied by 100. 1.08 divided by 3.96 multiplied by 100. That's 27.27%. 0.6 over 2.2 times 100. 0.6 divided by 2.2 multiplied by 100. That's 27.27%. From here you can see that no matter the method used for preparation, they both would have the same elements combined in equal proportion by mass. Okay, so now let's move on to another law. Let's consider law of multiple proportion. Or is it saying you can't still hear me?
The wire is free now.
Yeah. Should I come over? Okay. We verified law of definite proportion. Now let's move to law of multiple proportion. This law states that if elements A and B combines to form more than one compound, several masses of A, now several masses of element A will combine with a fixed mass of element B in simple whole number ratio. Let me write that down. If two elements A and B combine to form more than one chemical compound, then the various masses of element A which combines with a fixed mass of element B are in simple whole number let me take that. Law of multiple proportion states that if two elements A and B combines to form more than one chemical compound, then the various masses of element A, which combines with a fixed mass of element B, are in simple whole number ratio. Let's consider carbon and oxygen. We have CO, this is carbon monoxide, and we have CO2. This law is saying that if these two elements combine to form more than one chemical compound, in this case, then various masses of element A, that's oxygen, will combine with a fixed mass of element B, that's carbon, are in fixed whole number ratio. They are in simple whole number ratio. Consider copper and oxygen. We have copper 1 oxide and copper 2 oxide. You can see, right, that several masses of copper will combine with a fixed mass of oxygen. In case of CO and CO2, the atomic mass of carbon is 12, right? 12 plus oxygen, which is 16, and that will give us 28. For CO2, we have 12 plus oxygen is 16 multiplied by 2, that's 32, and that would be 44, right? That means if we break this down, let's break it down. 2 will be 14, 2 will be 22, right? 2 will be 7, and 2 here will be 11. Am I correct? That means fixed mass of carbon will combine with oxygen, which are various masses. Carbon in copper and oxygen also the same way. Let's solve a calculation question to verify this law. Two oxides of sulfur, A and B, we analyzed. And the result obtained